Hello friends, upon completion of this lecture, you will be able to compare and construct microprocessors and microcontrollers, explain the concept of embedded system, determine criteria before considering a microcontroller, compare and construct the various members of the AVR family. Okay, the number 4 types of problem you will know about this session. Okay, uh, first, what is microcontroller and microprocessor? Okay, the microprocessor is an electronic component. It is kind of computer processor that resides on single or multiple integrated circuits, that means IC. This IC contains many other electronics components such as a resistor, a transistor, diode, etc. etc. The microprocessor performs all the functions of the central processing system. One way it differs from the CPU as it occupies small space and resides on only a couple of integrated circuits. It does not have I/O peripheral component and internal memory, so it requires external components such as RAM, ROM, timer, serial interface, I/O port to operate. How does a microprocessor work? Microprocessor holds the number of instructions. Every instruction consists of multiple steps such as fetch, decode, executes, and store. While running instruction in the microprocessor, it executes multiple steps as fetch the input, decode instruction, execute instruction, store result back in the memory. Here, instruction gets fetched and input to is even using external I/O components. The microprocessor executes an instruction. The result gets stored in the externally connected memory unit. Okay, then what is a microcontroller? The microcontroller is the electronic device. Okay, microcontroller is the electronic device. Uh, the microprocessor was an electronic component and the microprocessor is the electronic device. It has its own processing unit along with fixed size ROM, RAM and other required peripheral components. These all the components are embedded on the single chip. These all the components are embedded on the single chip. As it has all the components required to process and store data, it is also called as a mini computer or computer on the single chip. Then again I am saying, as it has all the components required to process and store data, it is also called as mini computer or computer on the single chip. Okay. Uh, what is databus? Databus has general purpose microprocessor CPU, RAM, ROM, I/O port, timer, serial ROM port, etc. The what? mm, okay. What is the difference between microprocessor and microcontroller? In microprocessor, must add RAM, ROM, input-output ports, and timers externally to make them functional. In microcontroller, the fixed amount of on cheap ROM, RAM, and number of I/O ports makes them ideal for many applications in which cost and space are critical. In microprocessor, makes the system bulkier and much more expensive, and have the advantage of versatility on the amount of RAM, ROM, and input-output ports. On the other hand, microcontroller in many applications, the space it takes, the power it consumes, and the price per unit are much more critical consideration than the computing power. Okay. Now, microcontrollers for embedded systems. What is embedded system? You have to know what is embedded system first. Actually, an embedded system is a microprocessor-based computer hardware system with software that is designed to perform a dedicated function, either as an independent system or as a part of a large system. At the core is an integrated circuit designed to carry out computation for real-time operation. I again telling you, an embedded system is a microprocessor-based computer hardware system. An embedded system is a microprocessor-based computer hardware system with software that is designed to perform a dedicated function, either as an independent system or as a part of a large system. At the core is in an integrated circuit designed to carry out computation for real-time operations. Complexities range from a single microcontroller to a suite of microprocessors with connected peripherals and networks, from no user interface to complex graphical user interface. The complexity of an embedded system varies significantly depending on the task for which it is designed. Embedded system applications range from digital watches and microwaves to hybrid vehicles. Embedded system applications range from digital watches and microwaves to hybrid vehicles. As much as 98% of all microprocessors manufactured are used in embedded systems. And how an embedded system works. Okay, now how an embedded system works. Embedded systems are managed by mostly microcontrollers, and it may include other components like digital signal processor (DSP), application-specific integrated circuits that ASIC, field programmable gate arrays, that means FPGA, and GPU technology. These processing systems are integrated with components dedicated to handling electric and or mechanical interfacing. Embedded systems programming instructions, referred to as firmware, are stored in read-only memory or flash memory chips running with limited computer hardware resource. Embedded systems connect with the outside world through peripherals linking input and output devices. I again saying you, embedded system programming instructions, referred to as firmware, are stored in read-only memory or flash memory chips running with limited computer hardware resource. Embedded systems connect with the outside world through peripherals, linking input and output devices. Now, basic structure of an embedded systems. The basic structure of an embedded system includes the following components. 1. Sensor, AD converter, processor and ASICs, DA converter, actuator. Now I am telling you about sensor. The sensor measures and converts the physical quantity of an electrical signal which can then be read by an embedded systems engineer or an electronic instrument. A sensor stores the measured quantity to the memory. AD converter. An analog to digital converter converts the analog system sent by the sensor into a digital signal. Processor and ASICs. Processors access the data to measure the output and store it to the memory. DA converter. A DA converter, that means digital to analog converter, changes the digital data fed by the processor to analog data. Actuator. An actuator compares the output given by the DA converter to the actual output stored and stores the approved output. Uh, I think this video will be a long video, but I want to short out, so I decided to cut down this video right now. This second part will come tomorrow. Till then, happy everyone. Thank you everyone.